So this is another way of determining the answer, getting the answer, but with a graphing calculator. And that's what the calculator is using. Any questions? Any questions? Is this okay? Yes, please. Dana, go ahead, please. Yes. So I went to math, and you don't scroll to the right. In math, go up, and this summation notation will pop up. So it's 0 here. So you go up to 0, or just press 0, and this will pop up. Be very careful that in parentheses, if you have more parentheses, then you have to put parentheses, parentheses. Be careful. Now, if you'd like us to go back and check, since we were determining the sum of, oh, oops. So please make the correction here. I'm so sorry. I was thinking of I. So this is not the sum of the squares. It's the sum of I, or the sum of j. It's not the squares. There is a different formula for squares. I can show you the squares in a minute. So please correct that. My apologies. This is just I, which is 1 plus 2 plus 3 plus 4, just 1. Okay? And then I'll show you the formula for I squared or j squared if you want, or k squared. But this is just I or j. Sorry about that. So everything else is correct. I was thinking of I. Don't change anything else. Everything else is fine. So now we can go back, if you'd like, with the summation notation and check what we just said. So we have from x equals 1, and we said till 1,000, right? Right? From x. When I hit enter, I have to get that 500,500. Mandatory. Look, it takes a while. Even the calculator needed to think. This is not a very easy calculation. 500,500, as expected. Now, if we want the I squared, is a different story. It's a different formula. I'm so happy I went back to check that, because I wanted to show you with a calculator. Any questions for me? Any questions? Okay, so now we have plenty to practice. Please choose from 29 through 42. And I would like to choose a combination with the summation notation and factorials as well. Let's take a look at 42 on page 752. The sum from I equals 1 through 5, from I plus 2 factorial over I factorial. Yes, if you have this summation notation in the graphing calculator, then you can just plug it in. But I don't recommend it. I would like us to simplify a little bit. So let's take this general or generic term aside. Which one is bigger? Top or denominator? Top. So then the denominator will stay as is, and the numerator will become Can anyone tell us? Yes, I plus 2 times, indeed, times I factorial, so we can get rid of it. So now you can still use the calculator if you like, and we will, because now we know what all this means. But be very careful how you plug it in, because if you don't put parentheses around this product, then you're not going to get the correct answer. So let's do this together. So we go back to math, up to the summation notation. And we have from I, or in other words, x equals 1, till 5. And in parentheses, I have x plus 2, close the parenthesis, and then open another one, x plus 1. Yes, you can distribute and just not use parentheses and parentheses, and when we hit enter, that's the final answer. And you can check that by hand if you'd like. So it's 110. Any questions? Any questions? I think we should look at least one more. Please choose if you'd like, or I will. What about 36? On the same page, 752. So the sum from I equals 2 to 4 from negative 1/3 raised to power I. Oh, sorry. So 36, so this was 110. So in 36 we have the sum from I equals 2 to 4. So we have three terms here. When I is 2, when I is 3, and when I is 4, three terms of negative 1/3 to the I. So I just want to list these terms just one time. So this plus negative 1/3 to the third power plus negative 1/3 to the fourth power. That's all it is. With the graphing calculator, if you'd like, go back to the summation notation. And we have from x equals 2 till 5, till 4. And in parentheses again, negative 1 divided by 3, close the parenthesis, power x, and press enter. And that is the sum. 0.08642 approximately. So approximately 0.08642. Questions? Questions? Okay, finally, after all these two preps, factorial and the summation notation, we are ready to talk about sequences. This is really annoying. Okay, so here's how a sequence looks like. A1, A2, A3, A4, dot, 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 AN, dot, dot, dot. As you see, this does not stop at n, so it's called an infinite sequence. These are called terms. This is called a general term. And all it is a function. Nothing else but a function whose domain is the set of positive integers. For the first term, I have A1. For the second term, I have A2. So corresponding to the third term, I have A3. Now, we will be able to find sequences. We will be given sequences and we will be asked to find the general term. Another possibility is we will be given the general term to find some of the terms. Okay, so let's do just that. Number one, given the general term, find some terms of the sequence. Okay, so here's the problem. Please choose if you like, or I will. It says write the first 4 terms of each sequence whose general term is given. Let's start with 5 on 752. A sub n, which is the an, the general term, -3 to the nth power. And they want us to find the first 4 terms. Okay, so they want us to find A1, they want us to find A2, they want us to find A3, and they want us to find A4. So, what does this mean? It means that n is 1. -3 to the first power is -3. What does 8 sub 2 mean? It means that n is 2. So -3 to the second power is 9. Okay, what does the next one mean? It means -3 to the third power, which is -27. And finally, -3 to the fourth, which is 81. So how does this sequence look like? -3, -9, -27, -81, ... -3 to the nth power, ... That's how it looks like. And we determine the first 4 terms. And let's look at number 10. A sub n equals 3n over n plus 5. Same question. They want us to find A1, A2, A3, and A4. Can anyone dictate A1? Don't calculate anything. We want everyone to see what it means. Yes, 3 times 1 over 1 plus 5. The top is 3, the denominator is 6. So this first term is 1 over 2. Excellent. A sub 2. So it's 3 times 2 over 2 plus 5. So it's 6 over 7, and no one can simplify that one. What about A sub 3? 3 times 3 over 3 plus 5, which is 9 over 8. No one can simplify that one. And finally, 3 times 4 over 4 plus 5, which is 12 over 9. This one we can simplify by 3, which is 4/3. How will this sequence look like? 1/2, comma, 6/7, comma, 9/8, comma, 4/3, ... the general term, 3n over n plus 5, ... Do we get the idea? Once we are given the general term, how we determine at least the first, like we can determine any term. You can say, find A500. That's not a problem. If you want me to find A500, I will say 3 times 500 over 500 plus 5. It's not a problem. So it's going to be 1500 at the top, and this will be 505, and I will simplify a little bit, and I get the term, any term. So in this case, we are only asked to find the first 4. Some sequences are given not with the general term, but what is called a recursive formula. What is a recursive formula? Okay, let me give you an example. Problem 14. We are told that A1 is 12. This is given to us. And A sub n equals A sub n minus 1 plus 4, of course, for n greater than or equal to 2. So let's look at the difference between this term, which is the general term here. See, this is the general term. It does not depend on the term before it. But this one, this generic term, this time, it depends on the term before it. So A2 will depend on A1. A5 will depend on A4. A10 will depend on A9. So this is a recursive formula where we do not have a clean A sub n, a generic term or general term. We don't. Unfortunately, it is given to us, but it depends on the previous one. So now, in this case, if you want me to determine A100, if I don't have A99, I will not be able to give you A100. So now this is more difficult to determine. If you say find A100, I have to determine all the 99 before them, before that one. Here, there was no problem. Say anything. I'll plug it in and I get the answer. But here, I can't. So again, the same question. We're asked to find just the first 4 terms. But the first term is already given to us. A1 is 12. Can anyone build or tell us, don't calculate, we want everyone to see, what will A sub 2 equal to? Well, A sub 2 will equal A sub 1 plus what? Plus 4. But how much is A sub 1? Well, it's 12. Plus 4 is 16. Can anyone give us A sub 3 or A3, the third term? According to the recursive formula, you will say A sub 2 plus, exactly. Do we have A sub 2? Yes, we just calculated it. So plus 4, this will be 20. And we can go on forever. We are only asked to find the first 4 terms. It says find the first 4 terms of each sequence. So what will you say A sub 4 or the 4th term will equal to? Yes, will be A sub 3 and plus 4 according to the formula. That's what the formula is telling us. So it says 20 plus 4 equals 24. And we can continue forever. We are only asked to determine the first 4 terms.